Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability.
Imagine a world where hydrogen could be produced without using a single volt of electricity. No electrolyzers, no solar panels, no wind turbines, just heat, water, and a reusable material. That's not science fiction. That's the power of redox chemistry. Today we're going to unpack exactly how it works. Hydrogen is the fuel of the future, burning clean and leaving behind only water vapor. It's versatile, powering cars, trucks, factories, and homes. As the most abundant element in the universe, it offers zero emissions with no greenhouse gases. But making green hydrogen is expensive, and traditional methods rely heavily on electricity and water. 70% of green hydrogen's cost is electricity, with current costs ranging from $4 to $6 per kilogram, while the target is just $1. This is a major barrier to widespread adoption. But what if we could bypass electricity entirely? Enter redox chemistry. Redox is short for reduction and oxidation, two interlinked chemical processes. Oxidation involves losing electrons, while reduction is about gaining them. These processes are always paired. You can't have one without the other. This exchange of electrons is the engine behind chemical looping for hydrogen production. Chemical looping involves materials that can cycle between oxidized and reduced forms, while interacting with other molecules. By using metal oxides and steam, we can create hydrogen without electricity, just using heat. Let's look at iron oxide in action. Iron oxide exists in different forms that can cycle between oxidized and reduced states. When we heat iron oxide in a high-temperature environment, like waste heat from a steel mill, it sheds oxygen atoms. Heat drives the first reaction. When we heat iron oxide, it loses oxygen atoms and becomes reduced. We now have a reduced metal that wants to grab oxygen from somewhere. Steam completes the cycle. We introduce water vapor, and the reduced iron grabs oxygen from the water, producing pure hydrogen without touching the electric grid. The cycle is ready to repeat. This redox cycle is not a one-time trick. It's an endless loop. With just two inputs, heat and water, we can output pure hydrogen, with 2 cycles possible and 0 electricity required. This changes everything by eliminating electricity dependence, being modular and inherently safe, and using abundant and reusable materials. It transforms waste into value and makes hydrogen accessible anywhere there's heat. Heat sources are everywhere. Industrial waste heat is abundant in steel mills, cement plants, oil refineries, power plants, data centers, and mining operations. Most of this heat is currently wasted, but it could power the production of clean hydrogen. The material revolution is here. Redox materials offer cost advantages, reusability, supply chain benefits, and simplicity compared to traditional electrolyzers. Other materials like iron oxide or manganese oxide can also be used depending on temperature and efficiency requirements. From theory to practice, this process isn't just theoretical. It's the principle behind Thermoloop, developed by New Hydrogen Inc. It uses waste heat to create affordable green hydrogen, proving its potential beyond lab demonstrations. This is a global economic game changer. With a $1 per kilogram target, hydrogen becomes competitive with natural gas. Net zero goals are within reach, and waste energy becomes a valuable resource. Redox systems are elegant, efficient, and effective, the perfect combination for scalable clean energy. They don't reinvent the wheel, but apply smart applications to modern energy constraints, transforming waste heat into clean fuel. What's next? The scale challenge. From lab to industrial implementation, critical next steps include integration, validation, and optimization. Bringing systems to real industrial settings is key to unlocking their full potential. The industrial integration vision sees hydrogen generators embedded everywhere, from cement plants to chemical factories, power stations, and data centers. Imagine industrial facilities that don't just make their products, they also generate clean fuel from their own waste heat. Opportunities abound for investors, engineers, and policymakers. Early-stage opportunities in breakthrough technology with massive market potential await investors. Engineers face integration challenges, system optimization, and industrial deployment projects. Policymakers can harness industrial heat recovery for revenue streams and sustainability advantages. The path to a hydrogen economy is clear. Redox chemistry is the missing link, offering clean, scalable, affordable, and accessible hydrogen production. It could make hydrogen competitive globally through elegant application of established principles. Redox chemistry is the firestarter of tomorrow. It can produce hydrogen using only heat and water, eliminating electricity dependence. Chemical looping makes it globally scalable, and abundant materials make it accessible. This could be the firestarter of a cleaner, hydrogen-powered tomorrow.
Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode and